so today we are group number 54, consisting of me, the leader, Abdullah, my subordinate Yuga, and Shreyas. So what is the topic we are going to do today? The topic that we have chosen is MRAM, and why it's inherently better than the typical DRAM that we are using today, and the possibility of it maybe eventually completely making all the things that we are using today obsolete. So MRAM stands for Magnetoresistive Random Access Memory. And for explaining the operating principles, I will hand it over to my partner, Yuga.
Hi, so I'm Yuga and I'll be explaining about the working principle. So how this magnetic MRAM works is basically using the principle of magnetic states to store data. So what is magnetic state? So magnetic refers to the electrical resistance when a metal is put under a magnetic field. So apart from the DRAM and SRAM, MRAM uses magnetic states because DRAM and SRAM, they all use electric charges to operate, like this. So there's something called MTJ that stores bits of data in MRAM. So MTJ is basically magnetic tunnel junction. So this thing is made up of two ferromagnetic layers with one insulating layer that is sandwiched between two ferromagnetic layers basically. So how this thing works is basically by changing the resistance in the MTJ and storing logic 1 or logic 0 bit of data. So how this happens is when the MRAM has a high resistance, it stores 1 bit of data, and when the MRAM has low resistance, it stores 0 bit of data. So this is how it looks like. This is a reference layer on top and free layer on bottom. So when the electron spin on top, which is the reference layer, is same with the electron spin at the free layer on bottom, what happens is that there will be an attraction between these two layers. So therefore the current can flow through the MTJ easily, therefore creating 0 bit of data. So when the electron spin is different for both of the layers, what happens is that it will have repulsion between these layers, making the resistance to go up. So when that happens, the bit of data that is stored will be 1. So this is what I meant just now. So basically when the electron spin on top and bottom is the same, what happens is that you will have south and north aligned with each other. Therefore, the current that is passing through, the current will pass through easily. And if we have north and north aligned together, which means the electron spin opposite to each other, what happens is that the resistance gets high and the current cannot pass through it. Therefore, the bit of data will be 1, and here it is 0. Yeah.
So, hello, my name is Shreyas, and I'm going to be talking about the advantages of MRAM over the conventionally used DRAM. Now, DRAM is a type of RAM that loses its data as soon as the power is turned off. So when you turn off your computer, it basically clears itself of all the data that's there. But MRAM is capable of retaining its data even when the power supply is cut off. So that means we can boot up computers almost instantly because the data stored in MRAM is retained, and it can, instead of using data from the hard drive or the solid state drive, we can draw the data straight from the MRAM to boot up the computer. And MRAM is also longer lasting than DRAM, and MRAM is more durable, and it can withstand radiation. So it even has potential to be used in space exploration because in space there's a lot of exposure to various types of radiation, and as MRAM is resistant to it, well, it's the natural choice. And MRAM is also very energy efficient. DRAM requires a constant power supply in order to preserve its memory, whereas MRAM is capable of preserving its memory even without a constant power supply. And MRAM is also cheaper to produce than DRAM. So MRAM can be utilized for almost every single digital product that we have right now. These are some of the products that we can use it for: personal computers, smartphones, digital cameras, military use, space travel. And now I'm going to hand it off to our group leader, Abdullah, to conclude our presentation.
So what does all the advantages, every single thing that I've heard so far, what does it entail and what does it mean? What is the potential of this new device? And here I am to explain to you what exactly you can achieve with this. So MRAM so far has been in its infancy. There has not been a lot of development. But if we do manage to develop it so far, it is possible that every single device that we've used so far can actually be replaced with MRAM. MRAM is faster than normal RAM, it is more efficient than normal RAM, and on top of that, MRAM is faster than normal SSDs and NVMe, which is so far the fastest form of storage we have ever found so far. If with the possibility of MRAM, we can create computers which have zero time lag in booting up. We can create computers which have almost zero loading time that take, and in the end what this entails is that we can basically make extremely fast computers, to say the least. That is the best way I can say. We can make extremely fast computers, and there are also possibilities that for future space travel, if we ever penetrate in that market, we can use MRAMs as they are more durable than any form of memory we have ever made so far. So what is the conclusion of all of this? What this entails in the end is the fact that MRAM is an extremely promising feature that we have discovered. It may not be new and it has existed for some time, but due to recent developments in this technology, it can be the next biggest thing in the world. It can completely revolutionize the computer industry, and which is why several companies such as WD Western and all those big companies have already decided to invest in such a market. And with that, I would like to conclude our presentation. Voila.